Hello and welcome to this video from Unit C4, the periodic table. This video is all about transition elements. My name is Mr. Clee from the Darton College Science Department. So the aim of this video is that by the end of it you should be able to recall the colours of compounds that contain copper 2, iron 2 and iron 3. You should also be able to give examples of reactions of transition metal carbonates, be able to give examples of reactions that transition metals and their compounds catalyse, and be able to explain how you can use sodium hydroxide to identify the transition metal ions that might be present in a solution through a precipitation reaction. So, transition metals. Transition metals are this block here between group 2 and 3 and the periodic table. They're called transition metals because they have different states. There is transition between these states. They are all metals and they all have typical properties of metals. Shiny when cut, strong, malleable, that sort of thing. There is one exception there, mercury, which is obviously a liquid metal. So the key thing that you'll notice here is that basically the transition metal elements all form coloured compounds. You've got iron 3 here that forms this reddy brown, cobalt forming this red colour, nickel this green colour, copper this blue colour, and iron 2 this greeny colour as well. The exception on this slide is sodium sulfate. Sodium is not a transition metal, therefore it's making a clear compound. The three that you need to remember is the copper making this blue, iron 2 making this light green, and iron 3 making this orangey brown. This is the colour of rust. That's because rust is essentially an iron 3 compound. One of the major uses of transition metals are as catalysts. Here we have a picture of margarine because nickel is used to catalyse the hydrogenation of unsaturated fats in the production of margarine. An unsaturated fat is one that has a carbon to carbon double bond, and you want to break that and make it a single bond. Use hydrogen to do that, but you need to speed up that process by using nickel. Other examples are iron, which is used in the Haber process. You've also got titanium, which is used in a catalytic converter. You might have come across manganese oxide as a catalyst. You might have come across vanadium oxide as a catalyst. All these metals are transition metals, and their compounds can also be used. Another property of transition metals is that when you get a carbonate of transition metals, like this green copper carbonate here, when you heat it up, it will thermally decompose, which means it will break down into other products. Typically, a metal carbonate forms a metal oxide and carbon dioxide. This is the test for carbon dioxide. It's lime water. The gas is being bubbled through and it's causing it to go cloudy. Copper carbonate will break down to become copper oxide and carbon dioxide. You can see that here because the green copper carbonate is turning into black copper oxide. This happens for a lot of transition metals. It's one of the key features of transition metals is that they will thermally decompose. Right, the next bit is all about precipitation reactions. Now you've probably come across the word precipitation in terms of geography, something to do with rain. It's not rainfall in this case. The precipitate that we're talking about is a solid that's formed in a reaction. So what happens here is the solid's insoluble, you add two liquids together, they form this insoluble solid, and that's what a precipitation reaction is. When you add sodium hydroxide, because the sodium is more reactive than all the transition metals, it displaces the metal ion, and you form basically whatever metal ion you've got, that hydroxide. So here what we have is copper hydroxide, which is CuOH2. That copper hydroxide has this distinctive blue colour that you see here. Different metal ions give different colour precipitates, and we can use this principle to identify what metal ions are present in different samples. These are the three key ones that you need to know. You need to know that copper 2 forms this blue-like precipitate of copper hydroxide when sodium hydroxide is added, and you also need to know about iron 2 and iron 3. Iron 2 forms a grey-green precipitate when sodium hydroxide is added. That is iron 2 hydroxide, and then iron 3 forms this orange-brown precipitate when sodium hydroxide is added, which is iron 3 hydroxide. There is distinction between iron 2 and iron 3, and you need to know both the colours. Basically, the difference between the two is that they're just a different form of the same of the same substance. They've got the same proton number, but their electron structure is slightly different, so they form different ions. Here's a symbol equation for copper. So this is copper 2 reacting with the hydroxide ions to form copper hydroxide. The other ions involved are spectator ions. If this was iron 2, it would be the same. But if it was iron 3, we'd have to have a slight variation, because you'd have a 3 here, a 3 here, and a 3 there. I've obviously made a mistake because I was talking about iron 3 when I was drawing iron 2. Sorry about that. So in summary, the key colours you have to remember: copper 2 is blue, iron 2 is grey-green, and iron 3 is orangey-brown. Transition metal carbonates can be thermally decomposed into metal oxides, which also produces carbon dioxide that you can test for using lime water. You've also got the fact that nickel catalyses the hydration of margarine, titanium is used in catalytic converters, and iron is used in the Haber process. The final point is that in these precipitation reactions, sodium hydroxide reacts with the metal ions to give coloured metal hydroxides as precipitates, and the colours that they are stated at the beginning. Thank you very much for watching. If you've got any questions about this video, please see me, I'm Mr. Clee, or any of your science teachers.